Okay, welcome back. Today in module number 7, we are going to talk about identity and access management. Now, we'll be focusing on various types of authentication methods. We'll understand these methods, that it is a crucial form of authentication and it is a backbone of the security protocols for protecting both individuals and organizations. So if we'll start from understanding the authentication types, it means that the authentication is a process of verifying the identity of a user, device, or other entity in a computer system, typically as a prerequisite to allowing the access to resources or systems. So in that, we'll have different categories like something you know, something you have, something you are, somewhere you are, something you can do, something you can exhibit, or someone you know. So let's try to understand one by one that what is it and what are we doing over there. Something you know means that it's an authentication method based on the knowledge only, and the user has, for example, such as a password or a PIN number, something that you can memorize and you can keep it in your mind. Now, I have a unique strategy of memorizing the passwords. You can find the video on my channel where I am teaching you that how can you memorize the passwords on your fingertips. So you don't need to have a password manager. All you need to know is a technique which would help you in memorizing all passwords for years, and you don't need to even write it in the notebooks or use any password managers. So the components of it could be the password, PIN code, or a security question. So example could be logging into an online bank account with a password that you know or which is there in your mind. Then we have something you have. It's an authentication using the physical item the user possesses, for example, a security token or a smart card or a key fob. Accessing a secure data center with a smart card could be an example of it, but usually it is a smart card or a security token that you possess in order to authenticate it to that device. Now then we have something you are. It's authentication based on the biometric identifiers unique to the individuals, like your fingerprint scanners or the facial recognition systems or iris scanners, etc. Example is if we'll unlock a smartphone using a fingerprint recognition or face recognition, that is an example of something you are. Then we have another topic of it, which is somewhere you are. It's an authentication based on the user geographical location, for example, geographical location, IP address verification, etc. If we like to access sensitive project files, only when you are within a secure office, you'll be able to access it. Likewise, if we want to block access to the user account, since you know that you don't have any offices anywhere else and most of your employees are accessing the services from within your country, so you can define the geographical boundaries on it, that only if you are in the country you'll be able to log in and authenticate to the systems. Otherwise, it would deny access to that. Then we have something you can do. It's an authentication based on actions the user can uniquely perform, often authorized through the behavioral biometrics. For example, the voice patterns or the analysis or the typing dynamics. Example could be verifying a user identity based on the unique pattern or the typing on a keyboard. So these are the examples of something you can do, which is based on the things that you do yourself in a different way. Then we have something you exhibit. It's an authentication based on exhibited behaviors or traits, not categorized strictly as biometrics, like behavioral patterns, like interaction with the devices, etc. So using gate analysis as the part of multi-factor authentication systems to control the access of a research lab, etc., could be an example of something you exhibit. Then we have someone you know. It's an authentication involving identity confirmation through another individual, usually used to understand social engineering threats, etc. For example, vouching a reference check by trusted individuals. Example could be a new employee gains access to the development tools after a referral and the confirmation from the known team lead. Only then you'll be allowed to access those resources. So these are the topics which falls under the category of understanding authentication types. Then we have techniques for strong passwords. These are the strategies and methods used to create passwords that are different to guess or crack, thereby enhancing the security of it. Now we have different components of it, like complexity, length, and unpredictability. Now complexity is incorporating mixture of uppercase, lowercase numbers, special characters, etc. So we can also say that if, for example, if you're using a complex password, each additional character that you would type, it would introduce into a password, drastically increasing the effort needed by an unauthorized party to guess or crack it. By using a variety of character types, you can effectively create a more diverse pool of possible password combinations, making it exponentially harder for the attacker to succeed using the automated tools of cracking the passwords, etc. Then we have length, which is the recommended password, should be minimum, for example, 12 characters, etc. Now, onto the password length. This is the most effective method of having complex passwords when you have longer password as compared to having minimum character length of 8. Think of it in a way like each extra character is an additional layer of defense against the potential intruder. The longer the password, the greater number of total combination that will be required in order to crack the password. Unpredictability is encouraging the use of random sequence rather than predictable patterns. Now we can think of it, for example, if we'll have a policy where each password must meet a certain criteria. Not only this would enforce a robust standard of security across the board, but it would also educate the users on the importance of each element of the password that you are suggesting or creating. Regular updates on these passwords, say every 3 months, can also mitigate the risk of long-term exposure from the exponentially or from the potentially compromised passwords. Now, example could be, again, the policy that would require the users that they can have a longer password, and then after every 90 days, they will be supposed to change the password. Now, the password policies could be organizational guidelines designed to manage the password creation, handling, and usage in order to enhance the security. Again, in this one, we have complexity requirements, change intervals, and secure storage practices. So if we look at the complexity requirements, specific rules about the composition of the password should be there. Like when an organization sets a specific rule for the password composition, it ensures that every password used within its system can withstand common attacks like brute force or dictionary attacks. Now, this involves a combination of characters, letters, numbers, symbols, etc. that can create a strong defense against attempts to infiltrate our accounts. Change intervals mean regularly scheduled password updates to mitigate the risk of the password aging. Now, we all know that passwords aren't meant to be permanent. Over time, the exposure risk of any password increases simply due to the potential data breaches and the increasing ability of the hackers to crack older passwords by new algorithms, etc. By mandating a regular update, organizations can stay one step ahead, constantly renewing the first line of defense, which is the password. The stronger the passwords, the difficult it would be for the penetrators to gain access to our systems. Then we have secure storage practices, which are the methods of hashing and encryption used to protect the stored passwords from unauthorized access. Now, these secure storage practices are critical because even the strongest password can be compromised if they are not properly protected. Techniques like hashing, as mentioned, or encryption, etc., or transforming it into a non-readable password, it would help us in making sure that people cannot easily decrypt the password. So if it's saved and someone gains access to the database, still your information would be secure. Now, example could be a company policy could be that the password must be changed every quarter and cannot be reused within a year and must be stored using the cryptographic hash functions like salting, or this would ensure that the security, even if the access to the storage medium is compromised, is intact. Now we have advanced authentication solutions, and in this one we have single sign-on, federation, SAML, zero auth, OpenID, shibboleth, and then we have LDAP, etc. So if we look at single sign-on, it would allow a user to log in once with a single set of credentials and access multiple related systems without re-authenticating themselves. This means that logging in once and having access to all associated systems without being prompted to log in again each time, it simplifies the user experience and enhances the productivity while maintaining the security. So the example could be that an employee would log in to their company's portal and gain access to both their email and HR systems automatically. They don't need to provide the password over and over again. The other one is federation. Federation shares the identity information across multiple IT systems or organizations to enable single sign-on capabilities across systems and boundaries. Now, this concept extends beyond single sign-on. Federation uses shared identity management across different organization boundaries because it allows systems to trust different identities provided by the external entities, enabling users to access resources across different systems, their home or the organizational credentials, etc., seamlessly and securely. So, the example could be a partner companies using a federated single sign-on will allow the users to access services across both firms without multiple login attempts. Then we have SAML, which we call as Security Assertion Markup Language. It's an open standard that enables single sign-on for web applications by exchanging the authentication and authorization data between parties. Now we can think of it as a way for one service to trust the login confirmation from other services, which is especially useful in achieving the single sign-on across different systems that might not inherently trust each other. So the example could be using SAML authentication. Users who are using or accessing the cloud applications provided by different vendors, they'll be able to authenticate it. Then we have OAuth. It's an open standard for accessing different delegation used to grant websites and applications across their information on other websites. Now, it is a widely used authorization framework that enables the third-party services to exchange the web resources on behalf of a user. It's what allows apps to let you log in using credentials from those services like Google or Facebook, etc., which are provided by them, and they access it using the resources without exposing the password. So the password is a website allowing, the example is a website allowing you to log in using their social media account without exposing the password. Now you might have seen that there are websites like if you'll try to access them, they give you an option that you can log in through the your Google account, LinkedIn account, or Facebook account, etc. They are actually using OAuth, and that's what they are talking about over here. Then we have OpenID, an authentication layer that allows user to log in into multiple websites with single set of credentials. So we can say that it is like enabling the users to be authenticated in a decentralized manner. This means that your OpenID credential can be used to sign in to any service that supports OpenID, offering the user-centric method of accessing a wide range of web resources. So for that, example could be using an OpenID provider to log into various online forums and e-commerce websites. Then we have Shibboleth, and for this one, an open source project that provides single sign-on capabilities and allows sites to make informed, authorized decisions. Now, Shibboleth is among the pioneers in federated identity management and web single sign-on. It allows sites to make informed, authorized decisions for individual access of the protected online resources in privacy while preserving it in a special manner. It is heavily used in educational institutions and research communities worldwide. Example could be, again, the universities and different administrative resources which are using it. You might have seen LDAP, which is usually linked to Microsoft, a protocol used to access and maintain distributed directory information services over an IP network. Now, just like single sign-on, federated identity, or SAML, or zero auth, OpenID, etc., we have a thing called LDAP, As the name says, it's a lightweight directory access protocol. This is a protocol used to access and maintain the distributed directory information services over the Internet Protocol. LDAP is used to store the information about the users, groups, permissions, and widely implemented for the user management as part of single sign-on. Now, a company can use LDAP to store and retrieve the employee information from the central directory during the authentication process, etc. Now we have different level of or types of access controls. We call them DAC, MAC, RBAC, ABAC, or access control lists. So if we look at DAC first, it's a system where the access to resources is determined by the resource owner who decides who can access the resource. This model gives the owner or the owner of the resource the power to decide who else can access it. In DAC environment, users are responsible for setting their security policies for their files, while they'll allow them to grant or revoke the access to anyone who fits the criteria. This flexibility makes DAC widely used, but can also increase the risk of large leakage if it's not managed properly. So the example could be an owner of a file on a personal computer allows specific users in their group to edit the files or to access those files. Then we have mandatory access control. It's an access to the resource in a controlled or centrally authority based on a security clearance levels and classified as data. Now, unlike DAC, MAC does not allow resource owners to have a say in the access policies, etc. Instead, access rights are regulated by a strict policy enforced by the system. Now, these policies dictate that who has access to what resources based on the information clearance and the classification, etc. MAC is known for strictness and is often employed in environments where security is a paramount, such as the military installations, etc. Now, in government systems, example is classified documents, etc. are not accessible to the users, which appropriately requires certain level of clearance, etc. Then we have role-based access controls, and access decisions are made based on the roles designed to the users within an organization with permissions to perform certain operations defined by those roles. Now, RBAC restricts the network access based on a person's role within an organization and has become one of the most prevalent methods. Roles are defined by a system administrator and users are assigned roles based on their responsibilities and qualification criteria, etc. This ensures that the employees only have the access to the information necessary to perform their jobs, etc. Now, if we'll take an example of it, a HR employee can access the employee records but cannot access the financial records like their salary, etc., which are reserved for the financial department only. Then we have attribute-based access, which we call as ABAC. It's an access control decisions are made by evaluating attributes or the properties of the user, the resources, and the environment against a set of policies to determine the access rights. Now, attributes can be related to the user, the resources to be accessed, and the current environment context. ABAC provides a flexible and fine-grained access control framework capable of dynamically adjusting the permissions based on the wide array of attributes. Example could be a system grants access to a project management tool. If a user or the department attributes as a project manager, and the current time is within the business hours, only then they'll be able to access those resources. In the last, we have access control lists. These are the lists used to control what operations are different user groups can perform on a particular objects like files or directories, etc. Now, each entry in a typical access control list specifies subjects and an action. For example, if a file has an access control list that contains, for example, Elise can only read, it means that the user Elise is allowed to read the file. Now, a network administrator sets the access control list on servers, directories that allows the technical team members to read and write files. By marketing team members can only read the files. Now, these access control lists are usually there on the switches as well. We can even define these policies on different devices where we want to allow certain things to be accessed, whereas the other things would be blocked. So that was our lecture as far as the identity and access management was concerned. Oops, sorry for that. But if you have any questions, please feel free to leave a comment. That's it for today.